Nice, you got the big one, right?
No, the room is good.
Yeah,
Thank you.
yeah.
How are you going?
Good, how are you? It looks like Michael's not responding to your emails. I don't know what his deal is.
I can talk to you.
Oh, okay.
Nice meeting you. Yes. Yeah, thank you. Thank you. So I'm broadcasting this on the internet. You can see it on YouTube and Google Plus. It should be visible.
We should try and, when we do start a weekend here, I'm wondering, I need to test their bandwidth and make sure that 150 people can destroy their IPs or their access points and make sure it stays up.
Oh, they will destroy it comfortably, no problem.
I'm worried about that. I don't know what to do with that. Maybe I'll bring a bunch of routers in here and go. Is that, have you tested like a direct connection yet? Is that what you're doing, or is this all wireless?
What I'm doing right now is connecting to a website which can show you OpenStack.
Networking very well?
Sorry?
So I'm wondering if I should bring like a 24 port Cisco switch and just run some Cat5 around.
So similar to that is what I'm doing. I'm doing a four port open source switch right there. Okay. It runs Tomato, if you haven't heard that name, but it's a router software, open source software, and it runs Linux. And that's what the box is running.
What's the value? Is it for security?
No, the value is that it becomes converts a $100 router into a $600 router. Yeah. So it gives like all the capabilities that Cisco will have.
Layer 2, layer 3.
Everything. Yeah. Open source. Do whatever you like. That capability you can get from this piece of equipment now, provided you run open source firmware. That's what I'm running right now.
So, can I buy a cheap 24 port and do that?
Not cheap. It has to be good. And the hardware has to support. So the thing that we use is called Tomato firmware, or the better one is actually GTWRT. Okay. WRT. This is a piece of software that converts your $100 router into a $600 to $800 router, essentially. Practically speaking, there's a database of routers that you should select from. Okay. And from that database, once you've selected appropriate, you just type in your numbers that you have here, whatever model number you have, ASUS.
It's pretty much a firmware.
Yeah. Are you using it as well? Or?
I had an older WRT54G where I actually did that.
Yeah.
That's pretty sweet, actually, if you look at that. So Jason, can you please quickly check if are you able to see the Hangout on here?
I got a Chromebook.
Sweet.
Yeah.
Chromebook is good. I mean, it's just effective.
Yeah.
So you go to Google Plus and there you go. The Wi-Fi is called Cloud Genius. And the password is Cloud Genius.
So is this content something that I can promote through Startup Bellevue as well?
Yes.
Okay.
Yes, it's actually live as we speak. So we can go to say Google Plus page, and there you should find.
I wonder then if I did like JW Player on my site and I got your feed, could I live stream it there too? We should do that.
Why JW Player? YouTube will do it automatically, right? It does it automatically.
Oh, cool.
So that's what I'm doing right now. See that?
But people's stuff will hit play though, right?
This DDWRT picture?
Yeah.
It's showing already. It's already streaming.
Oh, that's cool.
So I'm streaming my own screen, which is streaming.
Oh yeah.
So it's like infinite mirror.
What is the value of?
No. The value is
JW. No value.
The value. JW is also free, but the hooking up is not a reward. If you want to skip. So when something like this gives you a ready-made solution, why not use it?
Oh, when you're pushing into your Google, you're pushing your YouTube account, it's back to your Google everything, then I can access that.
Yes, and that's how I think you should set up. In fact, that's what I'm doing right now. Is I have a Chromebox running a meeting or Chromebox for meetings. You know what?
Yeah, I wanted to buy that's the Asus one, right?
Asus Chromebox for meeting, $999. Not cheap.
Oh,
yes. Yeah, and if you have, it's a Core i7 processor, big machine.
Yeah.
And if you do beautiful meetings, no problem. HD, 1080p, wonderful meetings. In fact, it supports 4K resolution also. That's the beauty of it.
TriCasters in trouble.
I know. So that's the beauty of it. Let's
That's interesting.
let me open up my.
What's your name, man? Oh, I'm Jason.
Jason, see that? Mike Hannigan. Yeah. How's it going?
So going good, man. How are you?
Good, good.
I'm trying to remember the face of it.
Straticore.
That's right.
Yeah. I was
Cigar.
Yeah. Arguing another car.
So how's things going? So Linda reached out to me to be involved with the startup weekend, which would be good.
Oh, startup weekend?
Yeah, we're doing the startup weekend here actually at college.
Oh, right.
Here and at LB.
Oh, good.
Michael?
Yeah, hi. Yeah, nice to meet you too. Yeah, that's right, English. Nice to see you again. How have you been? Pretty good. Good. Yeah, thanks for putting this on, guys. It's really good.
These kids, I was just saying that Straticore was the one that was really interested in having you teach this course, but making sure to focus on fundamentals a little bit as well.
Yeah. I think fundamentals is the way to go. In fact, most people don't focus on fundamentals. They focus on a product. They try to sell the product so much that people just dilute the whole thing. So why are we doing this again?
Right.
That funda is missing.
Yeah.
That's the focus. I keep it agnostic to any one company. Go fundamentals. Go talk about nuts and bolts.
Yeah.
Give hands-on. So much hands-on that people can get bored to death and run away from the class. But it's okay.
Yeah, cool.
If they want to stay, they'll stay. If they want to run, they'll run. It's fine.
Right.
I think a lot of those guys come from, the Straticore, why don't you explain that? Because the company basically kind of brings in people that don't necessarily have the IT background, but they definitely have the telecom background.
Yeah.
Right? And so they need the cloud education because they're working with cloud companies that are using cloud, or they're, it's like a variety of different companies. But the more technical knowledge he gets here, the more dangerous of a salesperson he becomes.
I'll talk specifically about as to what I think can be interesting, especially in the context of what we're going to discuss today. I typically do not use slides when I actually teach you. I've seen that in my classes. There is no PowerPoint. There is no boredom. It's very high interactive exchange of ideas.
Nice.
The class is interaction. It is hands-on. Not much of me talking to people or my faculty members in other places. They don't talk too much in the class. There is no one-way stuff. It's a give and take.
You had a training on OpenStack, didn't you?
Thank you, sir.
Yeah, we did a little bit, kind of, we have our director of cloud strategy at the company, and yeah, we did some OpenStack stuff, but yeah, this would be kind of hopefully more of a deep dive.
Yeah, because Aaron knows his stuff with OpenStack. And stuff as well. That's the topic.
Yeah, Lee, Aaron, we have, Josh is a new manager there now too. What's the event called? It's a weekend, that's a startup weekend?
Oh yeah, we're doing, so it's startup weekend in Bellevue, and the theme is on cloud elements, right? So we'll be talking, hopefully, tying in the bridge between the startups and then thinking that they shouldn't be learning what he's teaching, that that's what they're dead wrong, right? And having that DevOps on their team, it enhances their chances of success.
Right. Okay.
Because you can scale when your company actually starts getting at 10,000 a day.
Yeah.
If you don't have that person that understands how to scale properly, your business will be closed.
Yeah.
So I think let's start. It is 6. So we'll start on time and not keep you too long here.
Great.
So my initial discussion, like you already mentioned about briefly, you talked about this thing, switching screens right now. We talked about this aspect of people attending the class, the curriculum, and what do they actually get from. So the coursework that we have runs in 3 locations right now. Our current locations we have are in Redmond and in Chicago, and the New Jersey is not showing up. So 3 locations we have where we are training, our faculty members are training these classes on cloud computing specifically. And here is a couple of things that the people who just graduated from my most recent class, let's see what they have and what they mentioned, what they talk about. So I'm going to play a short video. This is like a 1 minute 45-second video. Watch him what he says.
My name is Shahul Hamid, and I work for Expedia. I'm a director of technology for Expedia Data Warehouse team. So my role is predominantly managing the infrastructure and operations of the data warehouse infrastructure. Cloud Genius training helped me to change the way the Expedia has been operating, or the way the team structure has been operating. So I've been in a job for the last, I would say, probably 7+ years of managing the traditional databases, data warehouse implementation. Now, the learnings I get from the Cloud Genius help me to get into the next level of leveraging the either internal cloud or external cloud, using distributed computing on the cloud, or using a different messaging infrastructure with elasticity. These are all the concepts I gained a tremendous experience from the Cloud Genius program. Now I feel really strongly confident that I can apply the same skill set on the new strategy we are going towards, and apply the same skill set on implementing and supporting the new technologies. I was working on these traditional manner. Right now, when I just took this new role, I'm slowly merging into the new role. If I were like 3 months back, if you asked me, I would be really on the dilemma, okay, should I take this role or continue for the 6 months and things like that. But now, after I attended, maybe even after 3 or 4 classes, because I started gaining that confidence. Then after a month or so, then I decided, okay, let me take this new charter, and definitely I'll be able to succeed on this one with the learnings I got, and then continuous support from relations.
So there are more videos, but I don't want to play all of them. I would rather focus on what we want to accomplish. So having showed you that video, the way to access these videos is on the upper right corner. Go to that segment where we find an orange button. In the upper right corner, you will find more videos there as I keep adding. So that's one. The second thing I want to tweak a little bit is the display for people who are not with us right now. There are people who have joined in from other parts of the US. I want to make sure that they are able to see it. And I just got a message that somebody is not able to see part of it. I'm heading there right now. If it takes too long, I'll just skip the recording part and continue along with what we are doing.
I was going to message that somebody's not able to.
Maybe it got recorded. So where is it? Why is it that people are saying that? No need to end the other call. The call is working. So it is working. I'm going to leave to nothing. Back here on this screen. It is working. Hi. Please sign your name and address. Yeah. So our focus today is OpenStack, and make sure that you get the concept of what OpenStack is, and I want to leave you with enough information and content that you can run OpenStack on. You don't even have laptops, but I expected you to have laptops. But if you don't, that's okay. You know, any decent laptop which has like a 8 or 16 GB RAM, you should be able to run OpenStack right here, and I'm running it right now, and I'll show it to you. But before we get to the demonstration part, which is I want to make some announcements, and they are that our new class, next class is starting up again, which is September 8th in Redmond. 9th is in Tacoma in the Joint Base Houston Park. The start dates for here in Redmond, I mean this is Bellevue, in Redmond Lake Washington campus, the start dates is this, which is September 8th. It is Mondays and Wednesdays. It goes on like that, 3 hours every evening, 6 to 9 for 12 weeks. In addition to that, we also meet on Saturdays for 2 hours on Google Hangout, like it's going on right now. But you don't have to come into the building. You can just be wherever you are and attend the class, and that goes on like that. There are new coursework also coming up, which is it's a weekend workshop. This workshop focuses on OpenStack. hands-on. We'll use infrastructure available in the cloud to run OpenStack on top of Rackspace, for example, which is a cloud, cloud services provider. You probably already know. So we'll in this particular workshop, which runs on a weekend, Saturday and Sunday, 2 full days, intensive work, runs, gets you the hands-on experience you need without actually having a big machine equipment in your office, because not everybody can afford a machine in their homes as they're learning. So we'll simulate an environment right on top of Rackspace, which is a cloud provider, run OpenStack in that workshop. Then we also have a full day-long workshop focused on developer operations, DevOps. It's again hands-on experience focusing on a language called Ruby and a configuration management framework called Chef. It's a during the day opportunity to learn specifically DevOps and Chef. And we have a new coming classes focused on big data and analytics. It is not a administration class, but more of a business class that looks at big data, tries to analyze what kind of problems that businesses need to be solved. And for example, that video you saw, Shapul, the student that you saw from Expedia, what he's doing is in his data warehouse, trying to figure out what should Expedia do differently and present to their customers that show up on Expedia.com websites with good information that will make them incent them enough to buy tickets, buy hotels, rental cars. That's what they sell essentially. So any visitor that visits any of those 40 or different websites like hotels.com, Expedia.com, I don't even know what many .com they have, but all these sites are collecting some data. It's gathered in their office, in Shaul's office. They want to make meaningful insights, extract data out of that, get some insights out of it, and take real-time decisions. An example would be, let's say you're going to shop for a ticket to go to Hawaii, and you visit on some place and you want to buy a ticket. But you say, let me compare shop. And so the moment you close the browser window, another pop-up will come and show, wait a minute, I'll give you a deal. So think of it as a bad used car salesperson, essentially, practically speaking, but that's the idea of competing, is that you come up with a deal for the person who's not going to buy from you otherwise. So you identify that patterns of data of people, how are they clicking, how are they operating on your site. Compare to contrast that with data that you see from other locations that you also have relationship with in terms of exchanging data, and make meaningful action by taking specific things, get these insights out in real time, analyze that, and apply that to a business problem and solve it. That's how Expedia will grow going forward. It's the ability to convert each and every visitor on the site into a paying customer. That's what they want to have. They're not there yet. I don't think anybody is there yet. It's just random site visitors do not get converted by definition. They don't have 100% conversion. It's impossible, practically. So that's, you already saw the graduate videos. There are more videos if you want to see him, and some more, but I'll skip all that. I'll get straight to this, which is the aspect that we want to talk about today, which is OpenStack. And let me now begin asking you. I don't need the machine now anymore, so I can leave it alone here. I will talk to you about some of the concepts that you probably already know in the aspect of cloud computing in general. How do you define cloud computing? Let me ask you that open question. Any takers? What is your definition?
Just like infrastructure that's available as a service delivered on the internet.
Yes. What other aspects? Absolutely, that's a bingo definition. Yes, it's not complete yet. There are certain things that are also expected. What are those elements?
Like applications and storage and your network.
Yep. So there are organizations and standards bodies that define what is what. And once a standard body in this country is the National Institute of something, I don't know, NIST. Let's figure out what that is. NIST is probably
National
Institute of
Institute of
Standards and
Standards.
Technologies. The NIST. So they have the authority to define things, I guess, more than I have. So they defined it, and they have provided a formal definition of what cloud computing is. And so here's their definition. And it basically says, the cloud computing is ubiquitous, convenient, on-demand access, grow and shrink on demand as you like, and rapidly provision without having to interact with the service provider. You don't have to make a phone call to Amazon or Rackspace, but you can do it on demand by clicking a button, or maybe making an API call, things like that. And the entire activity is metered, measured. It's like a utility. Like electricity, you get electricity on demand. The problem with electricity is that you're stuck with the provider you have. In cloud, there is no such thing. You can switch the provider you like, any moment you like. You can switch from Amazon to Rackspace if you like. You can, in theory. Actually, in practice also. But from a Puget Sound Energy, you cannot switch from Puget Sound Energy to what? Again, we don't have a choice. So that's a problem in monopoly business. That's why they're regulated. Cloud is not regulated because it's not a monopoly. So it's demand and supply, it's pure economics. When it comes to that, these elements really matter. Essentially, it's talked about, on-demand self-service, which you already said. Elasticity, grow and shrink. When I don't need something, I can just get rid of it. Don't have to pay for it. Ubiquitous, you can, have it in your pockets. Phones are connected, machines are connected, laptops are connected. Resources can be shared, pooled, and measured. Meaning you can actually by minute measure. And so, for example, the cheapest machine you can buy on Amazon or rent on Amazon, essentially renting, is 2 cents an hour, something like that. Now translate that same pricing into a per minute pricing. That's what Google charges on a per minute basis, not an hourly basis. So they're measuring your usage by the minute as opposed to by the hour. So if you start a machine in Amazon, you will end up not using it for some reason. So you close it down in the next 2 minutes or so. Amazon will charge you whole 2 cents, complete, all of it, as opposed to Google will charge you only for the minutes you use. So it's per minute pricing. They're trying to compete in a different game. Essentially, it's going down the drain. Pricing is going down the drain, which is great for us. Exactly, that's what we want, right? And so OpenStack is an evolution of a bunch of technologies coming together in the industry. People like you have created it, contributed into it. And essentially, this is a representation of what cloud computing infrastructure as a service should be in the ideal situation. That's what they have. People like us, big companies like big name companies, and including government agencies like NASA, have put together efforts to construct this piece of software, collectively called OpenStack, which essentially enables all the aspects that you heard me talk about that defines cloud computing. And let's go into detail. So this is their definition of what they do. This is OpenStack definition. And people behind OpenStack is all of us. We have in some way, shape, or form, you have contributed to it. I don't know exactly what you did, but I know I have. I know companies have, and big names like these on the left, they have. And it started with Rackspace and NASA coming together to put together some components. Like these components essentially constitute what OpenStack is. And now I will go into deeper as to what these components are. So let's think of an example where you need a computer, and so you want a computer system for your usage. And these computers are not the ones that you are carrying in your pocket or maybe having on your tabletop. They're not these computers. They are server computers. They are away from you. So sit somewhere in the back room, sit somewhere in your data center. They are away from you. Those computers I'm talking about. So get a computer quickly, and I need that Dell server. So I go to Dell.com, look for the server, and buy that machine. It'd be like $600 to $700, and I'll bring it in my office, run the back office, keep it running. That's one scenario. But that's $600 lost because I may not use that machine all the time. If I need it just for 2 days, what do? I rent it. This concept is implemented by Amazon as EC2 or Elastic Compute Cloud. The same concept is implemented here in this open source software called Nova. That's the name they use. Essentially, it is a compute engine. What it does is give you computers on demand. So if you have a pool of machines, hardware, network components, the hard disks, CPUs stored up somewhere and collectively put together in form of OpenStack, you can on demand take a machine, use it, give it back. And it's all internal or within your company boundary. It doesn't even have to go outside your organization. It can stay all within. No need to even connect to Comcast or AT&T or any other kind of network provider. It's totally private. You can expose if you want, but don't have to. It is absolutely implemented. The best usage of this is private clouds, which most companies are heavily investing today for several reasons that I will not probably talk about, but you know that. You know what reasons I'm mentioning. Come on in, sir. How are you doing? So we already covered most of the presentation, but that's not what we're here for. I think we're here for the demo. So we'll go through that shortly. The aspect of Nova that we are talking about essentially is providing you computers, like servers on demand. So a similar example would be, if you go to Rackspace, you will find cloud servers as a product from Rackspace. If you go to DigitalOcean, you will find what they call droplets in the ocean, little servers in their cloud. Droplet in the ocean, that's their branding. If you go to EC2 from Amazon, you will find compute instances. That's their branding. But essentially, they are giving you machines to use on demand. They charge you an arm and a leg, maybe 2 cents per hour, or even less these days sometimes. Sometimes DigitalOcean will charge you $5 for the whole month, the smallest machine. And you can run it. And by the way, that machine comes with SSD, not just laid hard disk. So it's pretty darn efficient. Right? Have you seen those? Maybe I should show you. Let's see if I can pull up and show you what I'm talking about. I think showing is important. DigitalOcean. Did I spell it right? Yes. So let's go there and see what they have on offer. Falling prices? It's not loading. DigitalOcean. And what they offer is, oh, yeah. So they're saying deploy an SSD-based cloud server in 55 seconds. And the pricing is even more interesting. Let's see the pricing. $5 per month. SSD server in New York or San Francisco or Amsterdam or now Singapore also. So lots of locations, pretty good price. It's hard to beat that price. Even Amazon doesn't. And so the Cloud Genius servers are actually running here, by the way, the cheapest possible infrastructure you can get away with. So I pay them $5 every month. That's where I run, but you don't have to. You can run wherever you like because it gives you the flexibility of running wherever you have to or want to, depending on what your business goals are. So having said, back to what we were discussing was this aspect of Nova, which is essentially providing you compute instances of machines on demand. You take it and return it when you don't need. And all these resources are all within your corporate enterprise IT department. So these IT departments can then, within the company, allocate a machine for your group, a bunch of machines for your group, and it's all internal money. So it's funny money. And they can probably charge you $10 an hour, but it's all internal, so who cares? But CIOs tend to do that. Like they will have internal pricing, and they will have internal infrastructure. And what happens, the beauty of this comes from a private cloud setup, comes from the fact that sometimes the demands from one department may be low at one time, and another department may want more machines at the same time. We can balance off each other. So if you have department A, B, and C, and C has a constant demand all the time, they need machines, so many machines, so you allocate some machines for them, and they have it. These departments A and B are cyclical in nature, so if they can have a case where A needs more machines than B does not, and vice versa, then you can have and get away with only so many machines that you need for the overall corporation, while addressing the peak demands that A and B have at the same time, without spending over or without overspending, and at the same time keeping your entire infrastructure all within the company, right? Your questions?
Yeah, I have a question. What kind of machines do you get
or like $10 a month? What kind of processors?
Let's see what they give you. Yeah, that's a good question. Let's find out exactly what they do. We go to Digital Ocean. For example, just one example I'm going to pick up and work with that. And maybe give you one more example. Console. Amazon console. I'll faster. There we go, one. Digital Ocean, another. Let's do a comparison. Let's see what we get. So we have Amazon Cloud Services, and let's see what machines we have from them. So I'll identify and give you configurations, what we can actually get when we go to Amazon. So I'm going to say, give me a machine, launch an instance, then button I click, and I select some operating system I want to install there. So we want Windows or Linux or whatever your choice is. And so I select this operating system, which is now the open source OS. I select that. And then here I get sizes. So here are my sizes T2 micro to begin with, T2 small, and it goes on and on. So we can go all big sizes or all types of machines. I can go now describe what they have. So at the very minimum, T2 micro, that machine is one small vCPU, virtual CPU, and 1 GB of RAM, and internal storage, elastic block storage available. So very small machine, but it will run a little web server comfortably, no problem. And if you go to something like, say N3 large, this machine has 2 CPUs and 8 GB, roughly 8 GB, 7.5 GB RAM, and a 32 GB SSD included, and a decent enough. Are you seeing that thing here? Yeah, the blue highlight. It's kind of hard to see, but this line is what I'm reading. So depending on what sizes you want, the prices will also go up. As you go down this chain, the price will go up. Price per hour goes up. That's one example. The other example was this DigitalOcean example, which is this pricing. And the pricing is we have for $5 a month, you get 512 MB RAM, 1 processor, 20 GB SSD, and 1 terabyte of network bandwidth. That's the pricing we get from here. Now these are public clouds, so anybody and their brother and sister and uncle, everybody can access it. It's partitioned out, it's multi-tenancy, so you get your area, they get their area, and you can all play together, happy. But no interconnections are available, unless you explicitly call it out. So it is isolated, but still publicly accessible, unless you control it. And unless you open it up, nobody else can access it. But then some companies and some organizations want to keep everything totally private. That's what they call private cloud. And that's where OpenStack comes into play. It is your own infrastructure, your own everything, but you get the benefits of economic benefits of cloud computing in your company, in your organization. That's the reason why it is so immensely popular. And I also love it. And I run it on my laptop, this one. Did I answer your question?
Yes, thank you.
So, back to the topic we were discussing, which was NOVA. Any further specific questions on what NOVA did or does for a given private cloud setup with OpenStack? Any comparisons, analogies, or anything you want to discuss in that topic, so we can go to the next one, which is Swift. Swift is object storage. It's conceptually similar to, let me ask you, what is it similar to in Amazon space? In Amazon Cloud Services, what do they have that will let you store objects? S3 bingo. Absolutely. That's what this is an implementation of something conceptually similar to S3, but not identical to S3. It's different. The concept is same. You take a file, put it there. You take a really long file, you can put it there also. Doesn't matter. It's basically objects that get stored in buckets. That's what Amazon likes to call it. And Swift uses a slightly different terminology, but concept is same. You have containers or objects, they put in bucket. So if you have a box, you put your thing in there. A thing is a file, practically speaking. So you take a picture from your camera and you upload. That goes in a bucket somewhere, by the way. That bucket can be, suppose you have the Samsung. So you have both ones, right? So this will send you to Microsoft Cloud, yes, and this will send to iCloud, which is also, by the way, if you did not know, Microsoft. It's crazy. But iCloud storage is on Microsoft servers. It's really nobody knows. You can monitor your traffic on iCloud files as they go, and you will notice that it's going to Windows and your storage. That's where they have a contract apparently, and so it's stored there, which is sweet deal for Apple and sweet deal for me because I'm an investor. So that helps. Really sweet deal apparently that Microsoft offered to Apple. So that's object storage, where you take an object, put somewhere in some kind of a storage. So in your private cloud setup, it will be conceptually similar to you have a bunch of disks somewhere, and you allocate that disk capacity from a file system through Swift, which is the method that OpenStack provides, so that your applications can store a picture that you upload from your phone onto that cloud, which is your private cloud, and it gets stored inside Swift. That's the concept. Next item is block storage, which is, think of it as plain and simple hard disk that you attach as a C drive to your Windows laptop, or you mount it on your Apple Macintosh or your Linux box. Wherever you mount it in the mount point, that hard disk essentially is what this thing is. They call it Cinder for some reason. I don't know why. Maybe it's like Cinder block. It's block storage. And that's the reason why they chose that name, Cinder block, because it is storing blocks as opposed to files. And in that portion or that component of software, you can store blocks. Basically, store hard disk structures that you can use and mount to a machine and mount as a data, mount as an endpoint, read and write from that, and maybe boot an OS from that. Everything is possible in that context. You can boot from SAN. You heard the name booting from SAN. That concept, you can implement that in your private OpenStack cloud by deploying a boot disk in block storage. Put that in a Cinder, essentially, Cinder block, and then boot from it. That's the concept. Any questions on this? No?
This is like a PhD.
It is, exactly. So in Microsoft language, it's from Microsoft. Are you still with Microsoft?
Yes, yes.
Okay, good.
Well, I'm not this evening.
So yes, in VHD language, VHD is the word that virtual hard disk is the word that Microsoft uses with Microsoft virtualization software called Hyper-V. And in Windows Azure, that's the language that they use. The word they use is VHD. There are a variety of names, and I'll show you some of the names that you can use for that particular asset as you go to the demo part. The next item is Neutron, which used to be called Quantum before, but these are all funny names. Concept is very simple. You define your network. You define your red cable there. See that red cable there? The Ethernet cable? Conceptually, you define that cable and hook it up from one machine to the other machine, or a switch, or a router. That's what this software does. It's entirely done through software. But you're connecting machines, all virtual, with network, again virtual, and the red cable, figuratively speaking, also virtual. The entire switching is also virtual. And that is enabled through this software called Neutron. It used to be called Quantum, not anymore, because the name Quantum was patented by somebody. So it was a trademark somewhere, and they could not use the name Quantum, so they chose Neutron now. So forget all these names do not matter. Concepts do. And when you use it, you will run into these names, and they will generally refer to Nova and Swift and Cinder, and if you read OpenStack literature, which is all of it is open and available to you, you will not realize until you make these connections. What are they talking about again? Neutron. Dashboard is what you will see when the demo runs, which is a user interface. So conceptually, you saw this thing here. This is the dashboard. Right? You're looking at Amazon's dashboard. You can configure any of the services that they offer. They offer these services. and you can interact with, like a user as a human being, you can interact with their infrastructure that you have from Amazon through this website or portal or dashboard. And in OpenStack, you get similar to this, and they call it Horizon. We call it Horizon. A name choice for the rendering of the user interface, which by the way is another open source project called Django, the musician Django, not the movie Django. The musician on whose name another open source project in Python is built, and that is used as a backbone for this product. So that you will see once you start the UI for that particular service. The next thing is identity service. So if you're familiar with this thing called login password system, in very simple words. Have you used any kind of identity system ever before? Where you can get an identity, like an Active Directory or LDAP, those names. Are you familiar with these things? Concept is the same here, where Keystone will let you establish an identity. And so in your company, if you have an administrator who has access to the entire pool of resources, but then within your teams or within your organization, you have A and B and C department, then you allocate that this particular person from department A should be able to access only these things and not that thing. And that allocation and permissions and regulation of access, who can do what when, is controlled through this identity management framework. They call it Keystone because they store keys there at night. So that's the first thing you actually start invoking as you operate with OpenStack is Keystone. Then another product here, a component of the overall product is the lens. You cannot see the whole thing properly for some reason. Yeah, it's called glance, and that's where images are stored. To give you an example of an image that you know already, that you may have used. Some kind of image. Any example where you use a pre-existing image and started a machine from it. Have you?
Azure has the multimedia services that's really soon.
Except that it's actually an application level that we're describing. I'm talking about a machine level image.
On machine level.
So something like give me a Windows server ready to use. So I have that Windows server image, and I just take the image, put it on a disk, and then start from it.
Logs.
Yes, logs can be used to store image, and so this image service called Glance essentially is used to store either pre-provided images or custom images you create, of which you can create your own machines. Right? So an example would be that you have Red Hat or Ubuntu or Windows Server, or you name your own OS, and you create a pre-configured machine that you want your production usage for department A in your company. You have it prepared already. And now what you want to do is give everybody access to that particular image so they can just quickly start an infrastructure for that department A. And so these images are then stored in Glance. Ready to use images, quick and easy deployment of machines that you want for your custom usage. That will be Glance. Next is, I don't know how to pronounce that name, but it's telemetry, it's measuring. The word here is celometer, this word, celometer. It's a code name. It's basically about measuring. Who's using what, when, how, why, and how much they pay. Internally, these are internal funny money payments. Like I take money from left pocket and put it in the other pocket, that kind of money. So when you have a enterprise, you're running OpenStack within your company, company A will pay the IT department, then IT department will then justify the cost and all that internal accounting stuff. That measurement happens through this aspect of celometer. Basically measuring usage, measuring who did what, when, and why, and how much was consumed, so they can appropriately cross-charge your department. Like Amazon will send you a bill if you use that service, if you have a machine running in there, you have some other services you're using, they will give you, they'll put a charge on your credit card. And so they're actually monitoring when did you start that machine, how much did you actually use, how much data was transferred, where was it transferred, and then what charges are you should be paying. And that measurement is done by Amazon for their servers, for their infrastructure. In case of in the context of OpenStack, this particular component is responsible for measuring, metering. Then we have this new thing, so relatively new, these two last three things are relatively new. The aspect of orchestration, and I think I'll go a little deeper in these aspects to give you a perspective because it's not super clear sometimes what orchestration essentially is. So think of the orchestra, where the orchestrator is actually doing some waving of hands and making something happen. So what do they do when when it does this thing? What is he actually doing? What is he doing? The orchestra person, orchestrator.
Oh, it's to direct, just directing the orchestra.
Yes, he's telling everybody what to do when in harmony. Otherwise, something goes wrong and then there is no music. It's cacophony. So you want to orchestrate that entire game you want to play, or music you want to play, or whatever else you want to do in your business. You want to write that down in a very systematic, methodical fashion and run it, click of a button again and again, anytime you want. It's a predefined procedure. Think of it that way. And that's what orchestration essentially is. So the workshop that I mentioned about Chef and DevOps early on, that workshop goes into detail about how do I set up and configure a particular use case for a department A or department B in my company. And by the way, have it done in the next 10 minutes. An example would be, deploy my web application for accounting and billing in my entire company. And by the way, do it on 100 servers in the next 10 seconds, maybe 10 minutes. I'm just extending too much. 10 minutes is a reasonable problem. And so it's humanly not possible to do that. 100 servers in 10 minutes and pre-programmed and ready to deploy, ready to use billing servers inside the company and up and running in 10 minutes. Not possible humanly unless you have something like this that will configure it and deploy it on a click of a button and test it, validate it, and say that it is done in a matter of few minutes. And it's technically possible, and through this tool you can do it. It needs to be programmed. The name they have used is, I have no idea why they chose that word, but they did. It's only hot. That's where the heat comes from. Database services. The database as a service. So it's not what you think of, it's not running a database itself, but running a service to give you databases the moment you want it. And two types, both NoSQL type and SQL type, meaning relational types as well as non-relational types, both types of databases available as a service. So if you have, say, a program that uses MongoDB, for example, you can spin up a Mongo account or instance in, what's the name, Trove. In the Trove service, spin up, ask it to give me a non-relational database, and it will provide us a backend database running Mongo for you, and your application can then use that database as a service from within OpenStack deployment. That's just one example. If you happen to be running some kind of a RDBMS, say MySQL or PostgreSQL, you just ask for that, and it will give you both types, relational as well as non-relational databases. The name is, I don't know why that name, but that's the choice. And the last thing that we have now available in OpenStack is Sahara. So again, a code name. Sahara is probably an indication of the big thing. This is the biggest desert. It's a bad choice of name, according to me. But who cares about me? Sahara is about big data. It runs Hadoop for you inside your OpenStack implementation. What it does is take some machines, put some kind of Linux in there, enable HDFS on the back end, so your file system is redundant, and enable a master node, a bunch of slave nodes that you define, and enables an infrastructure where you can run your big data analysis and applications right in your all within your private cloud, right? In your private cloud. Sorry, I confused you. Did I confuse you?
No, I was trying to understand, what you two were saying.
Did I repeat?
Yeah, is that like, Elastic MapReduce, is that like Hadoop?
It is. So 2004, when I came to this state, at that time, two Indians wrote a paper for Google. The paper was called MapReduce. And based on that paper, Google implemented their search algorithm. The search algorithm is something that will help you find whatever you find quickly. Right? You know how does that do, right?
Yes.
Right, something it finds you that quickly, and it does it nightly. Every night, the entire internet is scanned for data and keywords and mapped, and then data collected from the mapping functions are then reduced to a presentable form, so that next day you come and search, you will find the information you're looking for. That's the mapping and reducing aspect of MapReduce. That algorithm of mapping and reducing to put these map informations together in form of a reduce function. That's the original algorithm that Mr. Gemala created in 2004. He works for Google. Based on that idea, and the paper went to public, some people in Yahoo, I think his name is Doug Cutting, who took that whole concept and implemented the entire algorithm in open source. And when he was working at Yahoo, and that algorithm implementation is called Hadoop. And the reason he chose that name was that because his child was playing with some kind of a toy, it was an elephant toy that he used to call Hadoop for some reason. So he just chose that name. And that's the name of the implementation that Doug Cutting created, which is a replica of Google's original paper of Map and Reduce. And now that Hadoop project has become really big. So big that most companies are contributing to it. There are big companies like EMC and Cloudera, Hortonworks, and another name that I'm forgetting, MapR, are creating their own derivatives of elastic MapReduce functions. Amazon has set up a new service called EMR service, taking Hadoop 2.0 or 0.2, I think. That version is still run 0.2 Hadoop. You can run your own Hadoop implementation on your laptop if you like, but it will be very, very slow and painful. And you will not like it, but you can technically run it. Same thing will be there when you run OpenStack on this little laptop. That I think we should now run because we just finished that discussion that we had about various aspects. But that implementation that I just described to you is Elastic MapReduce implemented in the name of Hadoop, and it is another open source product and available to you for free at this website called Apache Hadoop. You can download it and play with it right here and there. Right? So demo time now. Let's see if it actually works. So what I have is this thing. Are you familiar with what this thing is? Do you know what this thing is? Do you? Yes or no? This application that I'm running. Okay. So let me then give you some fundamental concepts before I start the demo. I have taken, let me describe to you what this is before I get into the demo. It will be pointless. So what I'm doing is running a virtual machine, and then running virtual machines and the entire OpenStack software inside that virtual machine. It's painful, it will be slow, but that's how you can do on your laptop. It's for learning, it's a great tool. It will be slow, I'm cautioning you, and you will fail probably 2 or 3 times as you set it up. I'll give you the script of how to set it up on your own as you walk away from here. So this software is running VMware. You can also do it on VirtualBox, which is an open source software that runs on Mac, Windows, Linux, and Solaris. Any OS that you have on your home or your work PC, whatever you have, you install a layer of virtualization on top. What it does is gives you the ability to run machines on top of machines. So have you ever done such a thing before? Is machine on machine. Okay. Hold on. And I'll demonstrate to you what I really mean when I say machine on machine. So what I'm going to do right now is not do the OpenStack demo first. I'm going to shut it. But instead show you the fundamental concept of machine on a machine, what that thing is. How many of you have used Windows XP before? I still use it. So that's what I'm going to run, and you can see that it is running on top of my Macintosh. You see that thing, a Hertz is a thing, machine on top of machine, the XP running on top of Mac, that's what you see right now. Here, this is it. So you're running XP, but where is it running? It's actually running inside a window. Watch carefully. Once it starts, I'll unmaximize it, and you can see that this is a window. See that start button, the familiar start button which is there, that one, that button. So this is what a machine inside machine looks like. But I'm amazed that you're seeing it first time. So I probably I should redo the whole talk again because I just assumed that you know most of these things. Sorry, I should have checked. I'm thrown off.
I think we get.
So machine on top of machine is the concept where you have to emulate, not simulate, emulate an entire machine. So it has to have a power button. It has to have a keyboard and mouse and display and CPU and RAM and everything. And it has to be exposed to Windows so that Windows will run. So where is my hard disk for Windows? Here. Where's my hard disk? There. And how big is my hard disk? It's 40 GB. You see that? Right. So that's my hard disk. Let's see how much RAM do I have in my XP machine. Where is my RAM? I have 2048 MB of RAM. See that? Here somewhere. Where is my mouse? I have no idea what my mouse is. It doesn't seem to move for here. But this is the RAM that I'm referring to. Right? I have two processors given to Windows, and I have 8 of them. And the laptop is big, actually, it looks small. In the laptop, you have, if you go above this Mac and more info, the Mac is actually big. And I have a display, I have some storage, I have 500 GB of SSD, and some memory. I have 8 GB of memory. I have given 2 out of this 8 to that XP here. Then I have a sound card. I can make music and play media player inside XP when it's actually audible. I can remove the sound card by clicking this button. And I can power off the machine by clicking this button here. That doesn't mean my Mac will power off, only the XP part will power off. So that's the concept of a machine inside a machine. And Windows XP is not hungry for power. In this machine, this box is big. It looks small, but it has 8 cores and 8 GB RAM and a large hard disk, a large SSD. So it's able to comfortably run machines on top of machines, and even a really big virtual machine that will cater to more virtual machines inside that virtual machine. So it's machine on top of machines is what we are doing right now. And so let me now shut down this XP machine. So it's shutting up. As I power off the machine, it just suspended itself. Now what I have here is this other machine, which is a bigger machine. It's actually very big. It's 4 gigabytes of RAM given to that virtual machine itself. That gives you the platform to run OpenStack on top of that virtual machine, because it will not run straight on a Macintosh. I need another operating system which supports OpenStack. And I'm using Ubuntu as the OS. Are you familiar with the name Ubuntu?
I've heard of Ubuntu.
Cool. So that's the OS that we are using, which is available from this website. This thing is called Ubuntu, the operating system. And by the way, they're also offering Jumpstart OpenStack training, which is they're going to give you this box. This box can come to your office for 2 weeks, and they charge you $10,000, and that's it. And then if you want some help, then they charge you for a person. Person will come to your office, you have to pay time and money and this. But that's what they are doing. Is giving you a 10-node cluster that comes to your office. 2 weeks, you play with it. They call it the orange box, and they're running OpenStack training. What I do is I don't use the orange box, I use Rackspace. So everybody can use it on your own. You pull in your credit card, you open a Rackspace account, and you basically set up 10 nodes there and play with it with your hard starter. And there's no time bound limit. You can keep using it if you like. That's the idea behind the workshop that I offer. So this is the software that I'm running on that virtual machine. These things are called virtual machines. They're running virtual machines, as in machine on top of machine. They're not real. They're fake. I mean, I cannot physically take it out, right? There's nothing to take out from here. Can I pull out the hard disk from this machine, XP machine? No. Virtual. It's fake. Literally fake. There's no other word to describe it. It is fake. It does not exist. But it works just like it is real. Right? The power button. You saw how the power button looked like. With a click of a mouse, I powered it up. Another click, it started up. So I'm going to start this machine, this Ubuntu Preside machine. That's the code name for that operating system that I'm using. And I'm going to a particular point in time, which I have saved. And that point in time is where I'm heading now. So in virtual computers, what you can do is take snapshots. It basically allows you to go back in time and back and forth in time any number of times you like. And it's a great tool for learning, because what it lets you do is, as you do some exercises and you want to learn something, and I can guarantee that I will make mistakes, when I'm doing something. So I want to now take a step back and do it the right way. And these softwares let you do that. They're also open source. So when I'm learning myself, I use open source VirtualBox, and that's what our class uses also. Is a virtual machine in the classroom. So all the exercises are done inside that virtual machine, which is like a fake computer that runs on top of your real computer. It is like a sandbox in your garden. You can create all the mess you want in your garden without disturbing your real garden, because you're operating and working inside a sandbox. And that's the configuration here, where you get to play with what you're doing as you learn and create mess. And enjoy doing that, because you're not going to hurt. And when you find that you made a mistake, you just take a little step back. That's what I just did. I just took a step back by reverting to a previously known good state, not known snapshot. And I know it works. I tested it before I came here. So that is the state that this window is running, which happens to be a big virtual machine. It has 4 GB of RAM. It has 4 CPUs. Let's see what we have. So when we talk, let's see. We have how much memory? 5,000 MB, so more than 4. More than 4 MB RAM, I have 4 GB RAM, I have given it. Then I have 4 processors given to it, 4 CPU, and some hard disk. How much hard disk did I give it? Hard disk, 60 GB. So these are the things you need to provide as you start your virtual machine that you will get from VirtualBox, which is this location. This is a company. This is now acquired by Oracle, but it is still open source. And that software is the first thing you need to start thinking about what I'm going to talk about, because it's a long process. But I walk you. So on your machines that you have, Windows, Mac, Linux, or Solaris, whatever you have, you download the appropriate binary, which is one of these 4 guys. Windows, you click here. Macintosh, you click here. Linux, you click here. And Solaris, you click here. And you download appropriate binary for your operating system that you have been using. Most of you probably have Windows or Mac. Not many people use Linux and Solaris on their personal laptops. But if you have a big laptop, like 8 GB RAM is minimum, only then you proceed, otherwise you just listen and do nothing. Maybe go buy a laptop and then install VirtualBox on that laptop. This will give you that foundation, that platform that you need to run an Ubuntu OS on top, and then configure that Ubuntu OS to run OpenStack on that virtual machine. So it's machine inside machine first, and then more machines inside that machine, right? So that's the first thing you need, is VirtualBox, which is an open source product. It was part of Sun Microsystems, and Sun was bought by Oracle. So now VirtualBox is part of Oracle. I used to work for Sun long time ago, 2000, year 2000. So this machine that you are seeing right now is just a black window apparently. If I click here, there's a login place. I can log in and give a password, and I'm inside the machine. So I can access the machine. That's the only user interface I have provided because I feel comfortable in the black window. Really, really comfortable. I love it. Terminal, it's called. That's how I use machines most of the time, not through UI. And I think it's a great way to use and learn because you don't really know what's going on in the black window. If you're comfortable with that, you probably have a great opportunity in front of you to do something meaningful. So having said that, it is asking me to reboot the system, which I will gladly do that, because that's when OpenStack will start running. So I'm going to reboot the system, and what I'm going to do is reboot only the virtual machine. As you will see, I'm typing reboot on the terminal window for that virtual machine, which will reboot just that VM, like this. So it is saying system is going down for reboot now. And so it is rebooting that virtual machine. My Macintosh will keep on working because it's real machine. Only the fake virtual machine is rebooting right now. And when it reboots, you have OpenStack running. I have done most of the grunt work already, by the way, before I came here. The grunt work that is needed essentially is to install VirtualBox first, then install a big virtual machine on top to have at least 4 GB RAM and 60 GB hard disk and 4 CPUs. So you need to have the real computer. That computer needs to provide 4 CPUs to that virtual machine, meaning if it gives away 4, then it has to have at least some. Which means you need a big CPU also on your laptop. A machine like this will not work. This is a crappy Chromebook. Yeah, this machine will not work. It's really, really small. It's probably smaller than my XP VM. My XP machine was 2 GB RAM. That machine is probably smaller. So now the this OS is rebooted and I'm ready for my demonstration. So I just quickly test and see if it's actually ready. And it is. It is ready. So it shows me that it's running OpenStack on a private IP address all within my virtual machine. So before I jump into the demo part, the demo is ready by it. This black window running in precise is that Ubuntu server running. And on top of that server, I did a couple of things. Once I installed that server, what I did was update the OS itself from Ubuntu app repositories, and then install a variation of OpenStack that is designed to work in small environments. If you run full OpenStack as you find in OpenStack repositories from open source, it will fail. You have to have some tweaks made to that source to make it run on small environments, because it assumes that you have large infrastructure, multiple computers, lots of hard disks, and lots of everything inside your company. So it assumes a lot of other things. In case of your laptop and you're trying to learn something, that is probably not true. And it's wasteful to spend that kind of money just for learning. And so from that learning perspective, there is a product, open source derivative of OpenStack called DevStack. It is OpenStack, but it's for development, for learning. So that's what I have installed here. And it's one line of command, takes 20 minutes after that, and it fails sometimes. But when it does work, it works like this. So let's now log in. onto that site. And there is a predefined username already called admin. And as you're setting up WebStack, it will ask you what password would you like to use. And so you can provide a password. So I have chosen some random password, and I'm going to log in like this. And what you will see is, it gives you the user interface, the Horizon, what was the name? Horizon was the name. On interface to using that infrastructure is now started. And this is how it looks like. It's conceptually very similar to HP Cloud. If you have seen HP Cloud, it's very, very similar because HP Cloud is OpenStack. If you have seen the new rack space, it is also very similar, look and feel, because the new rack space is OpenStack. And if you have seen OpenStack, this is how it looks like, because this is OpenStack. So let's see what's inside here. We talked about a variety of things, right? So let's see, system overview. What do we have? Nothing running, expected. I cannot expect to run lots of things here. Then we have hypervisors. These hypervisors are the containers for these state machines, or virtual machines. So I have no hypervisors active. I have instances, none. Volumes, none. Basically nothing, it's a blank empty state. So I will create volumes now. So if I buy a bunch of SSDs in my company and I want to allocate that resource, what I will do is attach those SSDs to a box and run OpenStack there. And I probably run Cinder in Swift and Glance and store my images, provide these volumes to the service that will provide PhDs in your language, or hard disks or Cinder blocks available to the infrastructure. And I'll also configure some part of it as Swift, so I can put my objects in the bucket, or my buckets, and various objects from a variety of teams. I'll configure the data structure accordingly. And so in this case, what it boils down to is I can configure something like create a volume type, and I will call it SSD. But guess what? It's not going to function like SSD because there is no SSD. Right? It's all fake. I can create a volume type called SSD. I'm able to create volume type on something. Volumes. Let's see what we have here. Do we have any existing volumes? None. Any volume snapshots? None. In the overview, let's see if we can create an instance. The launch an instance. Instance flavors. Oh. Aha. Sorry. Broken. This is Django error, by the way. So these kind of issues we will run into here to understand and analyze what's going on. I think that input will help. So a state that was preserved in my home before I came here is what I was trying to reproduce, and it doesn't seem to work in actual demo. But it works. You have seen it work, and you can get it too. Any questions on what we discussed up until now? No questions.
I'm actually running OpenStack at home.
On which flavor?
DevStack.
DevStack.
Yeah.
Sweet deal.
But I have a problem with every time I shut it down and I bring it back online, I'm not able to log in.
Yep. The solution is probably setting up a static IP for your VM. That's a recommended solution on, I saw that on GitHub.
Well, no, even if the IP changes, right, I'm able to bring up the page, the OpenStack page.
So the password doesn't work?
Yeah, it doesn't take it. I just tried it right now with my phone, and I'm not able to log in. So there's an issue with that. I don't know what the deal is.
Try latest binaries, latest from GitHub.
Okay. Try.
So the way to get that access is here. So this is where the developers of DevStack have stored their OpenStack derivative, which is also I think on DevStack.org. From this site, you will have these steps. Set up a fresh supported Linux installation, and then you clone your dev stack from this location, and then you deploy. Three essential steps.
Practically. Now, in your case, I would suggest taking a latest from GitHub, from a flash clone, or just do a git pull on the step number 2 here. Do a git pull and repeat. That might help. These things are developing all the time, so you have to go look at a stable version. So what you should do is maybe take this git link, go there. Don't know which version you have running there, so check that part. And the way to check this specifically will be drop down here and do a stable build. If you have all these older versions of the OpenStack software available, they are labeled as D, E, F, and G. They have code names for D, E, F, G: Diablo, Essex, Folsom, and Grizzly. And then after that, G is H, Havana, and I, Icehouse. I would suggest going here, like click this branch, and then take that stable. That stable will help you address the problem that you might have. In these instructions, they do not allow or do not advise that you go stable because they want development. They want people to go master like this. Because that's what, by the way, somebody was modified that code 2 hours ago. You see that somebody is editing it live. People are contributing left and right every single day. So from your perspective, if you want stability in your learning environment, I would suggest going to stable Icehouse, which in practical terms, it will mean something like this. You would say, after you git clone, when you're done cloning that thing, you do a git checkout. Stable Icehouse. And then you do that last step, which was this one. These are the steps I would recommend. As opposed to taking the master, take the stable. You see the difference? That will help you in getting stability, because that stable mark or the mark for stable version is put by a team, not one person. Somebody is defining what is considered stable and they're marking it so. So this stable Havana or stable Icehouse will not cause you problems, I hope. This was committed 14 days ago, as opposed to 2 hours ago. And the master was 2 hours, and there we go, 2 hours ago, and let's see what Havana was, probably on June 23, so it's old. I would suggest go Havana. At 14 days old is still too young. But the ability to identify a stable version and then work on it, learn from it, and then jump to cutting leading edge, like 2 hours ago, will be really bleeding, something will go wrong. So identifying a stable build and using that from learning perspective and even from production usage is a great idea. Like somebody will push an update for you, like Windows update or Mac update or Linux updates. Unless they are stable, don't take them. They have to be stable. And so Git and open source. The problem that you will run into many cases like you saw is people make mistakes. They're humans. And so 2 hours ago, somebody might have made a mistake and you happen to be cloning it at that moment. And then you have a problem. Unless you are looking at a stable checkout, then it will be stable because more than many people have actually marked it together as stable. And so they have tested it in some fashion. That's what I would suggest you trying out in these simple steps. Clone it and do this inside a VM that I suggested that you use. So build a big machine, big virtual machine, run Linux in that, and then clone DevStack from that location, and then check out the stable portion, and then run your setup like stack.sh, this last line,
and then it'll ask you for passwords and take 20 minutes or so to download stuff and install it, and then reboot, and then you have OpenStack that start running. And make sure you assign a static IP to that address, to that VM. It gives you repeatability and some predictability to some extent, right? Any questions?
Who's determining if it's stable?
Who determines? The real answer is people like you and me. And actually a consortium of people like you and me that actually test these things and collectively mark it as good. It's a team meeting of all the stakeholders, the people from Rackspace and people from NASA, who are main core contributors, who sit together in meetings every so often and decide what worked, what did not work. And they collectively get to make that call. You know what, that particular check-in should be marked as stable. And we will call it the Havana release or Ice House release. They basically going alphabetical, A, B, C, D, E, F, G, H, and now I. And then we will have J at some point. Right? So they collectively decide. These are people that know more than I do. They develop it. They decide that this is the right point in time, that snapshot should be marked as stable. And then that is considered stable because they know what they're doing. And the same concept applies to any open source project. The creators together decide what is considered stable. And take it to a commercial product. Somebody in that company will decide what is considered stable, and they call it Windows XP, SP2, stable. It works even today, amazing. And so the developers in Windows will decide collectively together that this is considered done. And so they will start selling it to make money. And subsequent Windows, I will not comment, but XP and Windows 7, yeah, pretty stable. It was a good decision. Windows 8 people don't like because they are not familiar with it. The device, I don't know what, and the start button is gone, and my wife hates it, and all that. But that's how the definition of stability comes from. It's the creator decides. The team of creators actually together decide what is considered stable. And they publish it and make big announcement that I'm calling this particular checkout as, or check-in as stable. You can then check out and use it in production. And they go behind it and say that we will support it also. Not commercially, but for community purposes, they will support it. And so you can ask a question and somebody will answer in probably 2 minutes, literally. If you go to a mailing list of these products and post a question, you will probably see the reply coming up right away. There are so many people involved in helping out everybody else. It's to their benefit also, right? They find an issue, they get fixed. That particular issue gets addressed. So that's the reason why people do that. And to provide community support is awesome. It's unbelievably awesome. Support from community is. It's hard to believe. Any amount of commercial effort cannot compete with that. No commercial effort will compete with that. It's impossible. And that is the beauty of open source. And that's one of the reasons why the entire curriculum that I have is strictly focused on open source. Absolute everything that I teach has to be open source, or otherwise I'm not taking it. We use it if it is free, but not teaching it. Like this DigitalOcean, they gave machines for $5. So we make use of it because it's affordable. We have to have some service provider to spend money on. The reason why we use that is that it works and it is cheap. Tomorrow, if something better comes along, we'll switch to that provider in the classroom. No problem. Just like that. It's the concept of what I call fungibility, or what is also, you familiar with this word fungible? It's an economics term. Fungible. It means like a dollar bill. Is a dollar bill? Is a dollar bill. Like my dollar bill or your dollar bill, no different. It's fungible. It's the same thing. Okay? iPhone 5 versus iPhone 5. It's the same thing. Unless you factory restore it, then it's the same thing. When you buy new, it's the same thing. Cloud from Amazon or cloud from Rackspace are the same thing? Not really. Practically, yes. It's a machine. You use it. You install your OS and you install your applications. You can make it almost fungible. So it doesn't really matter where you get your machines from. You pay the minimal for the price that you have to pay and use that. But it does matter if you're locking in yourself and your company and your business into some proprietary software that somebody will then regulate and charge you really an arm and leg, not 2 cents. That's hard. That becomes hard. That's one of the reasons why you see so much influence towards all large companies adopting open source big time, left and right. You see that everywhere. Every single company does that today, including Microsoft. If you did not realize that, including Microsoft, they have changed. In fact, the thinking that Microsoft has is, if you find an open source product, let's figure out a way to use it first before you write your own product. That's a standard operating procedure. It's a diametric shift from what used to be before. When I was there, we are not supposed to use open source, not look at it at all. Now it is completely different. Even Microsoft is using open source, left and right and center, and contributing to it. You can see Microsoft on GitHub. I'm not kidding.
Isn't it true that 30% of Azure runs on Linux?
Yes. My chef server runs on Azure. On Linux. Very beautiful. The beauty is, if you go to Windows Azure, you can find Linux instances, images ready to deploy. If you find something you're familiar with, you will use it. And so initially Microsoft started branding Azure as Windows Azure, 2013 professional edition. I don't know, sorry, kidding. A rollback. It was Windows Azure. Now it is Microsoft Azure. What they're essentially saying is it doesn't matter whether it's Windows or not. It's agnostic. You bring your OS, we give you the infrastructure you need, and you can run whatever you want on their public cloud. That's the message. It's the same message everybody else on the planet, like Amazon has, the Rackspace has, the HP Cloud has, the Cisco has, and IBM, by the way. All these people are also contributing to OpenStack and building out their cloud infrastructure on OpenStack, and are here hiring in Seattle. So right here. Cisco Cloud just announced $1 million investment in OpenStack and hired my friend there. Al, who used to be at Microsoft and then Amazon, is now VP at Cisco Cloud. And he's starting an initiative here. But then Oracle also the same thing. So all these companies are essentially taking open source software solutions like OpenStack, for example, and building out their cloud infrastructure to compete with AWS. So they can undercut 2 cents. I don't know where this thing is heading, but it's awesome for us, for users. Because virtually they're like making it cheap and affordable, right? It's really awesome for us. So it's party time, practically speaking. So we can build out our own infrastructure, our own applications, and our own services on top of these cheap infrastructure. So very good, but cheap. Very affordable. I'm not sure call it, but cheap is probably not the right word. Absolutely rock bottom affordable, but very high quality infrastructure. And you build out your infrastructure, you build your applications, and you provide value on top of these foundations that companies are putting together. They're fighting. It's a great thing. It's a great thing. In fact, I had a presentation on this specific topic that I talked about it in a webinar, falling prices. And there's a write-up, and there's also a webinar that I did with University in Illinois, where my class runs, Northern Illinois University. Here, so shut up. Okay. So this one is the webinar I did on pricing. It's it's an hour-long discussion where this professor who teaches for me in Chicago about what's going on in the industry from a pricing perspective and how we can make use of it. Because the essential beauty here is for us to make profit by using these infrastructure providers as a platform on top of which we can build our businesses or transform the way our existing business operates right now. That's the opportunity. Questions?
What's NIU?
NIU is Northern Illinois University. It's a university in Chicago. So here is that university. It's in Naperville, where my program runs.
You teach there?
No, I got the guy, Ige teaches that.
Oh, I see.
This guy. This guy teaches there. This guy.
Teaching in Bellevue.
I teach here in this state. Ige teaches in Chicago. Ige is a professor full time there, but he teaches for me when my class runs. This is my product. This curriculum that I have developed is totally my product, and the university license it from me and run it there. Like the university here, Lake Washington Institute of Technology, which is a public state institution, they have licensed it from me, and all they do is provide me a classroom, a place, parking, and a listing in the course catalog, and nothing else. The same with NIU, except that they given me a professor who teaches for me, but my curriculum. And same with NJIT, if you know NJIT, New Jersey Institute of Technology in New Jersey. Same thing there. You know this company called Sound Transit, like our company Sound Transit. Similar to that, there is a thing in New York called Metro Transit Authority. Maybe not familiar. But there is a thing like Sound Transit, in-country transit, like that in New York. The bus company, the tram company, the railroad company, God knows, 6 companies together, government agency. And they are running my class in their campus to teach their IT department because they are modernizing their infrastructure. And so one of my faculty members teaches there in their campus, in that location. Then we have another big thing happening starting next month, which is here. You know what this thing is? Joint base, Louis Mahar. So they have contracted with me to train our soldiers who are coming back home from Iraq and Afghanistan and wherever they are. And they are shrinking. Army and armed forces and air force are shrinking, which means that about 9,000 soldiers are getting let go to become civilians. And Obama has allocated a lot of money, millions of dollars, to train them so that they can get civilian jobs. And that class is starting September 9th. And they specifically focus on veterans in classic school. Because the class is quickly full because Obama is paying for it. There's a huge wait list. There are 60 people on the wait list, and the class is only 20. So that's the reason why it is so quickly full. One day I go to the base and I talk for 30, 40 minutes. People enjoy that. And we did like 3 or 4 such talks on repeat occasions in the last 2 months. And now we have it a long wait list. Just fancy. Especially getting a contract with them is awesome. So that's what we are doing. And this one is that you familiar with this location, Lake Washington in Redmond campus, in Marimore Park. At the north end of Marimore Park is where the campus is. It's an empty building because nobody goes there. Most of the people go to the Conference campus, which is the main campus. So the university really, really wanted something to happen in that building. And they found me. So that's where I have this location that I also teach. And that's where we have these guys. And also, you did not see this, right? So let's play this guy, see what this guy says.
Hi, I'm very well, and I work at Microsoft in the cloud with Azure. I joined Cloud Genius before I got this job. I was looking for a course which would enhance my knowledge and give me more confidence kind of for the interviews and working in my day-to-day life. Cloud Genius helped me a lot in gaining the confidence and knowledge I needed, which was missing in my life. The most important part of Cloud Genius training, which I liked about is the practical experience. It's an experience which one can obtain in the course if one doesn't know anything about the cloud, or even to a person like me who knew the cloud, or I thought that I know a lot about the cloud till I came to this class and got to know what I didn't know about the cloud.
So this guy got a job in Microsoft, by the way, with you. And this guy works in experience. So I have more videos I'm adding up slowly. It takes time to edit videos. It's hard. But I'm learning. So if we have further questions, what we do?
I just wanted to go ahead. Did anything off in front of the camera?
I have to check. Like that. That's the problem. I think I need to get that orange box from the Ubuntu side who saw me doing that thing. This box is what I need to buy now. And I do that. I absolutely do that for the class. Because this, running it on a laptop like this, is very painful. Very, very painful. Let me see if it actually works.
I got it running on my home computer. And now it works.
It works? Sweet.
So I'm able to actually run instances over there.
Wonderful. Awesome. Good job. I'm still having issues. I'm unable to take the instance list. No, it's not working for me. So we leave this alone for another. Maybe I'll do a web cast if you're interested on the weekend and do screen sharing and get you to set it up if you want. You need to email me for that if you're interested. Any other questions?
Yeah. If okay, so getting back to the OpenStack thing and the way it works and all that kind of stuff, right? It's like, let's say you're looking at a, let's just kind of.
Oh, you know,
yeah. Well, let's say you're developing a service, right? And let's say you want to potentially integrate it in with OpenStack, right? And the service evaluates resource attributes of the various cloud or instance or whatever you might call it. And apparently there's a couple of API, OpenStack has its own API, and apparently there's an EC2 compatible API or something that goes with that. But how would, and I don't pretend to be an expert at that level, I'm, more conceptual than nuts and bolts, right? And so, what do without getting into detail, maybe we could talk a little later about more detail. But so you're pulling resource attributes out. You're processing them in a certain way, returning the result. And do you see any issues with integrating that kind of a functionality with, obviously I didn't get anything in detail with OpenStack?
The recommended way I would recommend is to use this library. This library is called, sorry, I'm not away, I think. It's Ruby Cloud Library. And what it does, it gives you the API interface to connect with just about any company on the planet that is providing you cloud services. So let's see who are the people that are supported. And here are the names. You have the names like Atmos, AWS, Bare Cloud, Blue Box is by the way OpenStack, Brightbox, Clodo, CloudStack, another OpenStack, DN Simple, DNS Made Easy, Dynamic, Cloud. So all these Google, HP Cloud, another OpenStack. IBM, Giant, Linkford, which is a virtualization library in Linux. Linode, local is running the local hardware. Ninefold, OpenStack itself. OVID, Rackspace, in the long list all the way through. All these services are supported through this one common library. What you can do is as simple as clear gem install fog. That one line will install fog library for you, and you can then interoperate using the API fog provides. And you can do how to interface with that. So gem install fog, and then you fog arrive, and you interface with your provider. Like here example, if you once you have your OpenStack setup, you provide your API keys and keypad to a fog file, .fog file like this, and then you can invoke Ruby commands and interface with your cloud. Could be your HP cloud, could be Rackspace cloud, could be Amazon cloud, could be your own orange box sitting in your home or office that runs OpenStack. The box I showed you, picture. This box, this one. You get a credential from this machine, and you give it to Fog, and you can interface with it. And you can program this. So any attributes you want to extract from this unit, like the orange box here, or HP Cloud, or Rackspace Cloud, Amazon Cloud, you name your cloud, and you can do that through one library, this Fog.out.
And then what about coming back in and implementing things like access control, provisioning, and stuff like that?
Yes, through API, through command line, and through user interface that you saw that did not work. That one can enable access. The concept of access, I'll give you a simple example. That is probably a functional example, and that is with there you will find what I'm going into is IAM, which is the method of identity and access management solution available from Amazon Cloud. And I know it will work if I give you a demonstration. What it is doing is enabling you to set up groups. So I can then create a group, and I call the group called administrators. And I create that group itself and provide it full access, for example, and go along like that.
Right, good. Okay, no,
In this concept, we can do similar things in the Keystone for the whole OpenStack.
but I'm talking about not groups or roles or access lists or anything like that. Let's say there's another method that you're trying to implement that doesn't use what the methods available in the current offering.
Right, it will not work.
Right.
You have to interface with what they have.
Right, but if you think if they're set up on groups and roles and access lists and something, at some point you should be able to jump in there with another no-go access or provision.
So if you want to enable something that is custom and not available out of the box in OpenStack, you need to write custom code to interface what you have and what they offer. And then it will work. But just out of the box.
No, that's what I'm talking about. I'm not talking about just using what they have.
So, in that case, you need to define what your outcome you want and understand what they offer and identify the gap as to how you bridge that gap in your own code. So you need to write code that interfaces with what you have and what you want to what you got from, say, the orange box.
Right, and as I understand it, I do have some notes. I can't remember all this stuff, but I'm probably not the only one. But yeah, they talk about interfacing through the dashboard, right? You can automate access, et cetera, through the APIs or whatever, right? And I know I'm not giving you a lot of information and whatnot, but so yeah, not using the functionality of the application, if you will, but another method implementing. And you should be able to, are you, and I'm not necessarily asking exactly how, but so you can pull attributes out, resource attributes of what's going on, evaluate them, come back with a decision to do pretty much anything based really, I guess, on the limitations of the API. So
the simple answer to that is anything you can dream, you can code.
Mm-hmm.
So yes, it is possible.
And I'm not worried about the coding, once it pulls the attributes and it's just pulling the attributes and implementing them in the decision.
Right. Technically possible, provide storing. Out of the box will not work.
Right. And this thing fog that we talked about was how you see pulling the attributes out of the resources. Could be huge storage, networking, whatever, right? Users.
Fog is the Ruby implementation. There is another implementation, Python language, called this. Both of them. It is also equally good, except that it's Python. Very good library again. If you're a Python programmer, you will use this library that provides you API-based access to just about any cloud. Absolutely any cloud. Use this again, just like you saw in Fog.
Right.
This is Python-based photo, and it works. There are other libraries also. From an interface to identity and access management control perspective, you will have to write custom code. It is possible. Anything you can dream of is possible, but not out of the box. You don't expect OpenStack keystone to work exactly the way you dream. It may not. I can guarantee it will not.
Right. Right.
You have to code. You
Right.
have to code.
Right. It wouldn't be expecting you to. It's just a question of finding out where you jump in and jump out.
Mm-hmm. The easiest way to think in that direction is to understand what the outcome you want, see what you already have, see what OpenStack gives you, identify the gaps, and then start writing code or ask somebody to write code. Either way. There is the gap. And then you have your dream. And your dream will be different from anybody else's dream, right? So you have to write custom code every time. Dreams different.
Yeah. I'll just leave it at that for now, but maybe we can touch base.
Sure, you're welcome to talk. Absolutely.
Yeah.
Thank you.
Thanks.
Thank you for coming. I hope you all did sign up on the sheet, so I can sign back to you if you like. Are you Steve?
Yeah.
You work, no, Comcast is going to be private email.
Yeah.
Where do you work?
At my house.
Sweet. Me too.
Don't have to use Stack, is it? Is the Stack available? Slide Stack?
Yes, I will post it on the event right now. I email it. You have your email here, right?
Yeah.
Which,
Yes, that's.
how Gary, sorry for butchering your name.
Oh, yeah, it's
Okay.
almost right.
Almost right. Thank you. Thank you for coming.
Thank you.
Thank you. Thank you. Yep, sure.
All right, I'll meet you later, and you've got people to talk to. I just want to say how I'll be doing.
Thank you for coming. I'm doing fabulous, fantastic. I have absolute big things happening in my life, and I'm doing it. Amazing.
Okay. We'll try and catch up sometime.
Sure. Call me, email me. You have my email, right? Simple. So fine. Just do a Google search and you'll have a whole page. Okay. Nilesh at my last name, Nilesh at my domain.us. Watch on my Facebook, LinkedIn. Anyway.
Yeah, I'll check out. Just as funny as it is, I've fallen into the cloud thing recently. And in the right cloud stack.
You're doing private cloud now? Crazy. Microsoft does private cloud. Who uses Microsoft?
Hey, I get people to use it. That's my job for the next.
Yeah. So let's talk more about what you're doing. Yeah, I'll be interested.
Exactly.
If you make it open source, I'll incorporate them.
No.
Okay.
All right. Nice to meet you.
Did you want to go first or?
Go ahead.
Yeah, we can absolutely continue our conversation. Yeah, we can set up a time, talk, and all that good stuff. So, no worries there.
Okay. Well, I'll just explain a little bit. I just recently, after many years of funding, received a very broad patent, a pioneering patent on access control. And yeah, thank you very much.
Wow.
And according to NIST, there's only 3 methods, and this is one of them. And
What is the patent called? I'm sorry.
No.
Okay, it's not patented yet.
Yeah, issued. It issued.
You issued, so I should be able to find it.
It's all done. Yeah, but
So here is my patent. Let's see what comes up. Okay, there. So I patented this technique that was demonstrated to Bill Gates in 2006. It's about presence detection. Somebody's pinging me. But yeah, so about detection of physical presence. Are you home? Are you away? Where are you? In the car. You know, lots of implementations of it, but he like that demo. He hired me to a new team, which is now called the Link team, LINC. It is incorporated into Office 365, Word, Excel, PowerPoint, SharePoint, and all the red, green, and those bubbles that you saw. Or you remember that application? So that's the implementation on this pattern, which is mine, only me.
Right.
There it is.
As this one is.
Yep. So it should be visible. I'll be searching for you by the way.
Yeah, well, okay. That's
Find
good.
out what your
That's the
pattern
good-
is.
That's a good thing about a campaign. But anyway, but basically the method, it was evolved out of that enterprise integration platform, blah, 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 and it's a bit fighting with those guys for years and going references and all this kind of stuff, finally. Got it. It was originally developed at the application level, but of course, access control, since I have the time now, since I got it to kind of study, right, it applies out, it's a cornerstone of security. Application level, middleware, database, operating system, hardware, and the cloud. And so what I'm doing right now is mapping out what to do with it, right? Who the players are in fields that I don't know anything about, right? And so, and basically, it's a great method. The NSA and NIST are pushing it. The government has already recommended its implementation throughout, and all this without me having to do anything. I just got in ahead of the line without anybody knowing it. On the method, which is pretty
Nice.
fortunate. But anyway, so with this particularly, I mean, provisioning is access control, right? It's part of access and determining who has access. And if you're going to do automated real-time provisioning, you have to be looking at, forget all the security stuff for now, right? And enterprise stuff. Right now, we're just talking about the cloud and the provisioning. At some point, you got to know what's going on in the system if you're going to be provisioning things in an automated kind of real-time fashion. And this method enables you to look at resource attributes in real time and make those decisions based on not just the user's attributes, like identity-based or role-based, just really looking at the user and all that set up in advance static by an admin, right? Whereas this method is all can be just dynamic on the fly. Everything is situational, based on these resources, right? And so I'm sitting here going, okay, well, what the heck do I do with this? And so the reason I came tonight was because it's been clear for the last, since I've been doing this other research, that, the cloud and provisioning and OpenStack is a big part of that and whatnot. And so I'm just kind of wondering who the players are. It's clear to me that this industry is going that way already. Doesn't call it the same thing that I do or does or NIST does or whatever, but they're doing it. And so I'm sure there's people that are kind of infringing at some level already. Plus, just players and competitors and what we want to at what point. My plan with all this is just to build value like crazy and then sell it.
Right. I think it's a great way of thinking, although the first thing to be able to protect your IP is to actually have a published patent that is visible to other people. If they don't know that it is there, then they're not violating.
Right, and it is public.
Yeah.
It is public, and at some point, once it can be made a lot more public when the time is ready.
Yeah, exactly.
And whatnot. But so what I was hoping to do, and but we don't get out of your way. But basically at this point, I'm just trying to understand that at an implementation level. I'm not a hands-on coder, and I do have people in India that can do that and whatnot. So I'm looking at it more of a conceptual level.
My suggestion would be if you know that you have a patent, it would be a great idea to implement it.
Right.
And
Right. Well, and right.
absolutely bring it up.
I agree.
Show it to the world.
and see how you do it.
Right.
And that will prevent other people from copying it and potentially giving you royalty revenue or some other form of acquisition, who knows?
Right, and what I'm,
Make an exit out of it, right?
and what I'm trying to do, is select where I'm gonna go first, right? I can go after the application level. What I'm trying to do is understand the different levels, and maybe we could talk a little more in detail about sometime about this particular quote unquote domain, if you will, right? Like potential application, to see what's there, to see what I want to focus, you know, the security issues that need to be addressed in this real and virtual world are ridiculous. Just studying up on that as the access control, I mean, it's ridiculous with security and the way things are now, how easy it is to break into things and everything's running as root, right? And, you know, it's like,
Never run as root.
right, you know, the applications are made that way.
No,
And so,
it's a bad application.
right, and so, you know, there needs to be, you know, trusted computing having some problems, getting interactions, and all these other kinds of things. And so that's another area I'm looking at. I got the application and enterprise application and figured out, but this is definitely a big application for this method that is very hot. So
Implement it and put it on a box like this and show it. That works. Showing and demonstrating with some, you know, companies who are potentially encroaching and infringing on what you have created and created and conceptualized, implementing it and documenting it in a YouTube video will give you enough ammunition to fight.
yeah. And part of what I'm trying to do now at this point is in this world, in the OpenStack or cloud world, you know, who is trying to define who the players are and where they're at with things like this. Right? This wasn't my world, right? And so I'm kind of coming in and going, well, I know the method.
What was your word?
Well, I've done a lot of things. I've had a number of companies that also, I was chair of the MIT Enterprise Forum Venture Lab and demo and talk about companies how to plan, finance, and operate their businesses, done a bunch myself and whatnot, but I'm not a hands-on developer. And a lot of the things that I did weren't even in technology, you know, and so,
Yeah, I was also not born with the ability to code. I learned it after I was born.
Right.
Like some people are born with this ability to take pictures, but
Yeah.
Japanese,
yeah,
you know,
yeah,
born with the
with
camera.
all the cameras. Yeah.
Born with the cameras. So I was not like that. Actually learned it
Right.
on the hard way.
Right, and I'm not gonna be the one that does that. You know, I'm just be honest with you.
So everybody learns at some point, I think.
Right, and I did, and I've done, and I have at some level, and I know that that's not the best use of time.
Makes total sense. You know, so implement it. Ask somebody in some other country, outsource it.
Yeah, well, okay, yeah.
Yeah, prototype. Absolute do a prototype before you talk.
And so let me just ask you a couple of questions then. So you would see, I mean, in the definitions, right, access control, obviously there's all the things about access control. Provisioning is access control by many definitions, right, because you're providing access to the resource based on, and what you're saying is with like on the question I asked, within the cloud here, whether it's OpenStack or whatever, there's going to be ways of getting the attributes. And right now, you know, tagging is another thing I haven't completely figured out all that's being used for, but everybody's starting to throw attributes on resources. Well, why? So they can evaluate them to make these kinds of decisions in real time and be enforced. And so I'm just trying to map all that, you know, out. And so you think that's something we could have a discussion on sometime, or? Okay.
Yeah. But make sure you protect your intellectual property first before you talk to me.
Yeah, it's all
And
done.
I do not want to talk about anything that is private.
Understood. Understood. See, that's the beauty of the patent is, you know, it's like you don't have to worry about NDAs or anything at all. It's just you just go and discuss it, which is
Secret and private, do not talk to me because I talk to everybody.
right.
And I don't know what I'll say. So
I'll be honest with you, the whole thing still makes me nervous. This is pretty new, you know, it was only issued, you know, published in in June, and the protection date
Are we getting kicked out?
goes back to like 05. Yeah.
Okay, good. I thought you were going to kick us out. But no, thank you, sir.
But anyway, so do you have a card?
I do. And the best way to actually reach me is that. Not my card, maybe it's my card. Best way to reach me is Google. Yeah, I don't have a card. I don't know that.
Yeah, congratulations on the thing at McCord. That'll be a great deal for you.
Card is a big deal. I mean, they competed, like lots of big name companies competed. These are my former employer. Companies like Amazon and Microsoft and all these big names competed, and I won. Yeah, that's the way to go. And so, by the way, this is I am also listed as uh, 25 level certification programs.
Awesome.
Yes, you got listed.
Well, it is a hot area. That's one of the reasons, that I'm focused on.
But you know what? Just 3 years ago, I was at Blue in my home. What? What does that mean? That's me.
Yeah,
Now
letting the cat out.
Yeah, and now I am listed alongside these names, which includes Cloud School, UC Berkeley, American Public, this is American Military University, DePaul, Amazon Web Services, Bellevue College, Maryland College, Rackspace University, Cloud Security Alliance, CompTIA, IBM, Google, Salesforce, VMware, Red Hat, Microsoft, Cloud Credentials, Art of Service, CA Technologies, Learning Tree, University of Washington, NJIT, this is my program. For Cloud Master and Cloud Guru, different branding, but my program. Then we have AppTech, Hardware and Networking. I don't know them, and then this is Cloud Genius. My current brand that I'm actively developing this one now.
Right. Well, right on.
Yes, sir.
Yeah. All right. Well, hey, I'll send you an email or something. Like I said, I'm just kind of mapping out the landscape right now. And you seem to certainly be aware of it
In one line, my suggestion would be implement before you talk. That will save you money. It will make you a whole lot of money than you would otherwise.
But you have to talk, how best and more best.
My concern is do not tell me private info.
Gotcha.
I will not sign any non-disclosure because I have a big mouth. I openly talk about everything I know. Don't keep anything to me.
Fair enough.
Students.
Yeah.
Like I talk, every time I talk to a class, either it's Google, most of my classes are Google Hangouts. It's run, and then I occasionally go to these places and I talk, or I teach my instructors to go train. I speak my mind. I don't give thought.
Once it's in there, it's loose, huh?
Yeah, I speak my mind and do not rest it.
Fair enough. Fair enough. Well, see, the thing is, I want everyone on the planet to adopt the method. I mean, it's kind of here.
Implement it first.
Yeah.
That's the way to go. I've done it just exactly before I showed it to Bill Gates. I had an implementation in my home.
Right. Okay. Well, thanks.
Thank you, sir.
Yeah.
Hey.
So, I've been watching some of your videos online, some of the videos that I got from this video.
It's a short 2-minute video.
Yeah, so I actually did apply this video. I had an interview last week.
With this group.
It's administration, server administration.
Okay, is Shahul the person?
No,
he's
he's
the
not.
director of IT data warehouse there.
Really?
Yeah. He just changed to a new role.
So Kyle was the one that interviewed me. There was Kyle, there was another guy.
I don't know everybody, but I know many people there.
So I'm trying to switch. So what I do right now is I work for Apple. I manage 4,000 servers, 4,000 servers with clients around the world. But we are a Windows shop. I'm trying to shift to Linux, XP full Linux. Right. All local folks. And
They used to be a Microsoft company now.
yeah, they sold it, and now there are a bunch of other companies like Telecom, like you mentioned. So I'm taking my Red X exam next one that's coming in really fast. So I've been looking at some of your classes that you have, and my question is, am I gonna get a job after taking those classes, like right away?
I want to understand you a lot more than I do before I can make any such statement.
Okay.
But yes, it is very likely that you will absolutely learn relevant skills that will help you make a job. As you saw, you heard Shahul.
Yeah.
He was an existing director who attended my class. I mean, no kidding. He saw me talking, just like you saw me talking today.
Yeah.
He showed up in one of the sessions and he heard me talk and he liked it. And at the end of the session, he said, I'm going to sign up. I said, okay, welcome. That's pretty much it. The only interaction I had with him was that.
Okay.
I'm going to sign up. I said, fine. And then I went home, he went home. He showed up in the class. Great. But let me understand you a whole lot more.
Okay.
Before I make any random comments, because I don't make random comments and I speak my mind. You probably know this or probably know. So I will speak my mind. Tell me who you are. What do you know? What do you got?
What if I show him a resume?
Yeah, you know what? Nobody needs resumes.
Yeah, but here's the thing.
Nobody needs resumes. I'll see it. I'll see it.
Yeah, let me just show it to you so you can actually get an idea of what I do.
I'm also using an Android phone these days. I'm waiting for my iPhone. Thank you. Is it Android? Yeah, it is. It's calling it on. Shut it off. Somebody's watching it. You know, give me a second, I'll just shut it.
Yeah, go ahead. Go ahead.
The hangout should be shut off. Where do you want to grab lunch tomorrow? Okay, not right now. I'm going to shut it off.